Solving rational equations. So, given an equation we saw earlier, we now want to solve. One way to do this is to multiply the whole equation by the common denominator, which happens to be 12x. So if we multiply it by the common, 12x times this, the 3 will cancel with the 12, leaving 4 of it. So we get 1 times 4, because the x's cancel, minus 4 will cancel with 12, we'll reduce it to 3. So we have the 3 from here times the 3 of what's reduced here, but the x's cancel. 3 reduces the 12 to 4, so I get equals 1 times 4. And this will actually get rid of the entire denominators if we times by the common. So I get 4 minus 9, and this should have an x, equals 4x. Negative 5 equals 4x. X equals negative 5 over 4. The next thing to do is to ask, to check, is this in the denominator? If I were to plug this in, would it make a denominator 0? Is it in the domain? It doesn't make a denominator 0, it's in the domain, therefore it can be a solution. Say I was given 1 over t minus 7 plus 2 over t plus 7 equals 14 over t squared minus 49. Remember, this is t plus 7, t minus 7, if we factor it. So the common is t plus 7, t minus 7. T minus 7's cancel, timesing it to the first guy, so I have 1 times t plus 7, which is just t plus 7. The t plus 7's cancel, so I get 2 times t minus 7, which is 2t minus 14. And this one, the whole thing cancels, leaving 14. So I get 3t minus 7 equals 14, or 3t equals 21, and t equals 7. But wait, 7 would make this denominator 0. It's not in the domain, so it can't equal that. So this one has no solution. Because of that 7 not being in the domain, it cannot be a solution to this rational equation. Say we're given a different equation. For example, say we're given 2 over t squared minus 2t minus 8 minus 4 over t squared plus 6t plus 8 equals 2 over t squared minus 16. So first off, I'm just going to write down what they factor to become below in pink. So this factors to become t minus 4, t plus 2. This factors to become t plus 4, t plus 2. And this is t minus 4, t plus 4. So my common, what I'm going to times this whole equation by, has to have a t plus 4, has to have a t minus 4, and has to have a t plus 2. So on the first guy, the t minus 4's cancel, the t plus 2 cancel, t plus 4 is what it needs. So I get 2 times t plus 4 minus this one, the plus 4 and the plus 2 cancel, leaving the minus 4 needed. So I get 4 times t minus 4. This one, the 4 versions cancel, but the 2 one stays. So I get equals 2t plus 2. Distributing 2t plus 8 minus 4t plus 16 equals 2t plus 4. Combining like terms, getting the t's to the same side and everything else to the other, I get 4t equals 20. So t equals 5. Is that in the domain? Yes. Because it's not one of the values that would make any of these become 0, which would make it a divide by 0. Say, for example, that I'm given 2x over x minus 2 equals negative 3 over x plus 4 over x minus 2. So my common is x minus 2. That's what I'm going to times this whole thing. X minus 2's cancel on the first, it needs the x. So I get 2x times x. The second one, the x is canceled, but the x minus 2 stayed. So I get negative 3 times x minus 2. This one, the x minus 2's cancel, and we get 4x. So I get 2x squared equals negative 3x plus 6 plus 4x. 2x squared equals x plus 6, combining like terms. Getting everything to the same side, I get 2x squared minus x minus 6 equals 0, which this factors to become 2x plus 3 and x minus 2. Using the zero factor property, we can set both our terms equal to 0. Subtract 3. So 2x equals negative 3. X equals negative 3 halves. And add 2. X equals 2. So notice, are either of these an issue in this domain? Yes. 2 would make this 0. But negative 3 halves wouldn't make any of them 0. So this answer we throw out, this one we keep, because x equals 2 is not in our domain, but negative 3 halves is.